Hi, my name's George and I'm representing Team 60, Recipewise. So just a quick overview of our project. Passing an image of a dish and identifying its ingredients is not a complex task for humans. However, this is a complex task for computers. To produce systems that can achieve this, we created an end-to-end computer vision model that learns from image inputs and outputs the corresponding recipe. For our dataset, we used the food images dataset. It contains some labeled food images across 101 categories, ranging from apple pies to waffles. It consists of more than 120,000 images, as well as some 5,000 ingredient types. As part of the data pre-processing step, we did image loading, resizing, and augmentation during the training step, as well as scraping the ingredients for each food category. For the prediction flow, it works as such. So here, you upload an image of the food that you've taken, right? In this case, a salad. It goes through what we call a food classifier that we built, more on that later, which outputs the likely food that was contained in this image. Subsequently, you go through a recipe ingredient lookup, which then outputs the relevant ingredients, which in this case it supposedly includes Parmesan, salad dressing, romaine lettuce, and ribs. As part of the model fine-tuning process, we complemented the pre-trained ResNet image model uh, and trained it with the Food 101 dataset. Right? The deep learning model was done through PyTorch, whereas weights and biases was used in log training and evaluation metrics, as well as some model debugging process. So with this experiment management tool, we managed to come out with the food classifier model. So here, just very quickly, these are the training and validation loss using the weights and biases model. As you can tell, it's a pretty good set of results. We managed to get a final validation accuracy of about 90%. In terms of the deployment, the model was exported or traced using TorchScript. It was containerized using Docker and uploaded to Amazon's ECR repository. We also created and deployed a Lambda function for the image stored. Finally, we also created an endpoint using API gateway as well as Lambda URL. So now we'll just go through a very simple user journey process with the UI that the teams created. So here, let's upload something simple, which in this case is the pizza. Right? You see that everything's correct, so you do not click the incorrect button. However, let's go for something that's a bit harder to track. Right? So here you get the gyoza, right? Which isn't too far off from how the calzone sort of looks like, right? With all the flaky ingredients and whatnot. But in this case, because it's incorrect, you just click the below button. It sends a result that it's reported as the incorrect one. So what does this do, right? What does the incorrect button do? So here, every image is uploaded to the AWS S3 bucket. If the prediction is flagged as incorrect, the image is uploaded to the subdirectory incorrect for analysis later. So as part of our work, a lot of this is still iterative. We are still experimenting with Gantry for post-model building monitoring processes. We have also considered the use of natural language processing for any possible text inputs or joint embeddings depending on the input data involved. So that's all. Thank you.